Hi, geometry students. Welcome back for section 10.3. We're going to talk about arcs and chords and relationships. Remember, arcs are the portion of the circle. They're that curved portion. If I took it out, straightened it out, and worked with it. Chords are straight segments within. Their endpoints are on the circle. Our longest chord is a diameter. So there's lots of theorems to start off with, and there's lots of algebra in this section. So our first theorem, 10.2, in a circle or congruent circles, usually one circle like my diagram, two minor arcs are congruent if and only if their corresponding chords are congruent. So I could say something like this. If I know that chord FG, and I remember do that as a segment, is congruent to JH, then I can say that their arcs are congruent. That means if these two chords are congruent, that means that arc FG is also congruent to arc JH. So, and remember, if and only if says that I can switch the order of those. So if I know that the arcs are congruent, I can also say that the chords are congruent. So I could say something like, well, I know that the arcs are congruent. Arc FG is congruent to arc JH. Find X if chord FG is equal to 2x plus 7 and arc JH is equal to 3x minus 19. I could say you could figure things out. So if I knew the chords were congruent, I could say, oh, I can set up an equation and make the arcs congruent, or vice versa. So use that to your advantage. Again, that's just a setup for an algebra problem. You know how we do this. Our second theorem, in a circle, if a diameter or a radius is perpendicular to a chord, then it bisects the chord and the arc. Symbols in here, right? Everybody remembers perpendicular symbol, forms a 90-degree angle. So you can see in the diagram, I've got a right angle. So my diameter, BA, or my radius, CA, is perpendicular to chord TV. So I'm going to say if BA, segment or diameter or chord BA, is perpendicular to TV. So I've got that right angle there. Then two things happen. It says it bisects the chord and its arc. So this chord right here gets cut into two congruent parts. So I can say that TU is congruent to UV. I can also say that this arc gets bisected. So I'll put double on there because those are congruent to each other. And arc TA is congruent to arc AV. So it's another setup for an algebra problem. I could say, oh, well, I know this is perpendicular, and I know that TV is equal to 10. What's the length of TU? Oh, it's 5. Or I could say, I know that arc AV is equal to 15. What's the measure of arc TV? Oh, well, they have to be congruent, so both of them are 15, so arc TV is 30. So we can use that to set things up. Also be very careful when you see a right angle like that. If I drew in a radius, we'll talk about this as we go, but I could see some Pythag taking shape here. So don't forget about the Pythagorean theorem. All right, theorem 10.4. I told you there were a lot of theorems, right? The perpendicular bisector of a chord is a diameter. This is actually just the reverse of what we just talked about. If this chord right here, XY, gets bisected, so two congruent segments, and it's perpendicular, so perpendicular bisector, if those two things happen, then we know that AB is a diameter, or perhaps CB is a radius. So I'm going to say if, I'm going to put a Z here just so that I have a point. Oops, I missed. If XZ, segment XZ, is congruent to segment ZY, and CB is perpendicular to XY, then we know that AB is a diameter. It's exactly the opposite of what we just said. We use that one less frequently, but it does pop up. We could also say that CB is a radius if we'll just cut it in half, but sometimes the radius is what they give you. So that one's less so. The one before we'll use more frequently. Theorem 10.5, I think this is our last theorem. In a circle or congruent circles, this diagram, don't be overwhelmed yet, two chords are congruent if and only if they are equidistant from the center. So notice how in this diagram, I've got EG is marked as 10 and GB is marked as 10. So if EG is congruent to GB, now maybe they'll mark them as congruent segments with the dashes, maybe they'll mark them as 10 and 10, whatever it might be. But if those two things are equidistant, they're the same distance from the center G, so those two segments are congruent, then we can say that the two chords FD and AB are congruent. FD is congruent to AC. Kind of a messy one, but it's just another way to set up problems or to see problems. Remember, too, if chord FD is congruent to chord AC, we could go back to the first theorem. We could say also then arc FD is congruent to arc AC, right? If the chords are congruent, then the arcs are also congruent. There's one thing missing on this diagram. Ignore the dotted lines for a second. One thing missing in this diagram, the equidistant thing, when they mark this 10 and 10, they have to put right angles here. So I'll put a little mark. Must have right angles to show equidistant. The shortest distance from a point to a line is perpendicular, so you have to have right angles. They didn't put it on this diagram, that was my bad, but we should have right angles there. All right, so let's do a problem or two. So let's start with the example one, circle W. So I know that W is the center, right? So then I can infer that ML perhaps is a diameter. So let's see, it says radius WL is perpendicular to chord HK. It's already got that marked there. WL is perpendicular to chord HK. And chord HK is 16 centimeters long. I'll put it out here because I don't know where else to put it. And I forgot to mention the first sentence, this circle has a radius of 10 centimeters. I don't want to forget about that. Radius of 10 centimeters. I'll just highlight it for now. So problem A says if arc HL is, oh, I don't want to use black. Arc HL is 53. Remember, I'm looking at arc measure, so 53 degrees. Find the measure of arc MK. Oh, I really stepped it up. What if I said first, let's find the measure of arc LK. So this goes back to the theorem that says, well, if it's perpendicular, a chord and a radius, that means that the chord gets bisected and the arc gets bisected. So if HL is 53, what does LK have to be equal to? It's got to be congruent, right? That has to be 53 degrees. So now it's asking me to find MK. So MK, minor arc, take the shortest distance. Well, I could find this because I know that ML is a diameter. So I know that arc ML is 180 degrees. If it's 180 degrees from L through K, or from M through K to L, this half of the circle is 180. What does arc MK have to be? 180 minus 53 is going to get us like 127 degrees. I'm guessing that arc MH is also going to be 127 degrees. Letter B, it says to find segment JK. Notice, be careful, watch for arcs and watch for segments. Segment JK, well, this one we know, we sneakily know this, because if this whole chord we said was 16, the whole theorem behind this is that if it's perpendicular, these two guys are congruent to each other for the arcs, and these segments are congruent to each other. So the whole chord is 16, half of that would be 8. So JK will be 8, and JH will also be 8. Then it says to find the length of WJ. This is the interesting one, people, because if I wanted to find WJ, I'll put a little X on here. I don't kind of know things, right? But be sneaky. Our radius is 10 centimeters. We just found out that JK was 8. I'm going to draw in radius WK. And then I'm going to take this triangle out and just make a big mess so it's confusing. So here's W, the center of the circle. Here's J, where the right angle is. And here's K. WJ is my X. That's what it's asking for. JK we just found was 8 because that chord got cut in half. And we know WK. I know it's the hypotenuse of the triangle, but it is also the radius of that circle. What's the radius of circle W? It's 10. Here's what I was talking about before. We got a sneaky little Pythag problem happening. So 10 is the hypotenuse. So I'm just going to do x squared plus 8 squared equals 10 squared. I'm going to do some quick math in my head here. X squared is equal to 100 minus 64. That's 36. We all know to square root at the end. If you don't remember how to do Pythag, please make sure you ask. So WJ is equal to 6. And we've got ourselves an answer through Pythag. Letter D is my favorite one because people try to make this one really confusing, and it's not. It says to find JL. So JL, this segment right here. We did the work already. In part C, we found WJ was 6. Put a 6 over that. What is the length WL? WL is a radius, right? Use that radius everywhere you can. If WL is a radius and it's equal to 10, and we just found out that WJ was 6, doesn't this have to be 10 minus the 6? Doesn't JL have to be a nice, neat 4? Don't assume that that WL got cut in half, because obviously it didn't. But we can use Pythag to find the part of the right triangle, and then we can do a quick subtract to find the rest of that. All right, let's do a quick talk about number 2, because number 2 is so easy, don't overthink it. It says to find X. X is this degrees over here. This is the very first theorem we talked about. Notice I do have some helpful information, right? RS is congruent to ST. Those two chords are congruent. Well, if two chords are congruent, what do you know about their arcs? So 93 is the central angle. If I traced this out, right, ST is my arc that goes along with 93. So this is 93. If two chords are congruent, I know their arcs are congruent. Well, it's not drawn in, but this would be my central angle for arc RS, right? If the chords are congruent, the arcs are congruent, so X has to be equal to 93. the same as that other one. I think that one messes people up because it doesn't have that other radius drawn in. Arcs mean that or chords mean that the arcs are congruent. Those ones are so easy, they're difficult. I think this one, let's just talk about it for a minute. I've got two separate circles. We didn't do this. Circle J and circle K. Arc MN is congruent to arc PQ. They are already marked with a single dash. Find PQ. Well, PQ is a chord, right? This is the length of the chord. So PQ is this chord. Well, if you know that two arcs are congruent, then you also know that their chords are congruent. So we just do a quick 3x minus 7 equals 2x plus 1. Once you find x, don't forget that it asks you to find PQ, which means that you have to plug the x in to the 3x minus 7 and get an actual number. All right, let's do one more example. You could finish that one off. This one is a little messier. Chords EF and GH are equidistant from the center, which means here's EF, here's GH, which means that PQ is congruent to PR. That's what that equidistant is telling you. We also know, remember I mentioned, you must have a right angle here, so add it in if you need to. If the radius of circle P is 15 and EF is equal to 24, EF is equal to 24, don't forget the radius, I'll just highlight that so I don't forget it. Find PR and RH. PR and RH. So PR is this segment right here from P to R. All right, so here's the thing. We've got a couple things going on. If EF is equal to 24, GH has to also be equal to 24 because those two chords are equidistant from the center. So that means that the chords are congruent. So 24 for our GH. We also know that if that's perpendicular, we know that we've got this guy bisected. So technically, we actually found RH first, right? PR and RH, or RH has to be bisected. So that means that RH is 24 divided by 2, or 12. So this guy has to be 12. It wants me to find PR. I'm going to put an X on here. And this is like that problem that we did a couple minutes ago. I don't really feel like I have enough information, but couldn't I draw in a radius? PH, so let me redraw this. So P is here, R is here where the right angle is. I've got a dash there, double dash on here. This is 12, this is H, and X. PR is what we want to find, that's our X. Do you know pH? You sure do, right? pH is a radius. pH is 15. So I can do myself Pythag. 15 is a hypotenuse, x is a leg, so x squared plus 12 squared equals 15 squared. Let's try to do some quick math here. 225 minus 144 is going to get me something like 81. I like how these are coming out nice and neat. I don't know if you feel the same way. Square root both sides, and x is equal to 9. So PR is equal to 9. Watch out for those Pythag ones. They trick you because you don't see that you need to draw the hypotenuse in there, or the radius. The hypotenuse equals the radius when you draw that in. I think we're good with the last one. We'll talk about that inscribed trapezoid later. That is the end of section 810.3. Have a fabulous day, and I'll see you next time.